I'm the head of sales and marketing, and I also sweep the floors. The Flex 6000 series is our newest addition to the Flex family. We figure since it's our 10th year of being in business, we should come out with something totally new. So what we've done is we've created a new architecture for the ham space. This is a direct digital down conversion, so it's very broadbanded and brings in it captures the entire HF spectrum in one shot, stores it right into memory, and then we begin doing digital signal processing and manipulation and output on it all at once. So where our existing Flex series radios have a single conversion using a quadrature sampling decoder and only one mixer, this radio actually has no mixers. No mixers, no roofing filters, much higher linearity, very high dynamic range. And so that's the whole concept of this radio. One of the things that we determined is in order to get that kind of broad spectrum multi-receiver type output, this thing actually, the Flex 6500 can handle up to 4 receiver slices, a slice being a section of what we've captured. The 6700 with 2 spectral capture units actually can handle up to 8 receivers at once. And so in order to get that kind of processing, we had to move the horsepower back into the radio itself. So this radio here has the same compute power, not the same memory, but the same compute power as a mid-2000s Cray. So yeah, there's lots of horsepower inside the radio for doing this.
Now, is this vaporware or does this demonstration model actually work?
You are looking at real hardware that has been really powered up and really tested. As a matter of fact, in the manufacturing world, the point where we are now is we've released the build package, which means is that our manufacturing team is now bringing parts in, tooling up. We've done all the major testing. We've done all the major EMC and compliance testing. We're now just in the all we have left is finishing up mode to take ourselves to production. For our engineering manager, all we have left is just the software and finishing up. As with any project, there's a huge amount of software in this. As a matter of fact, there's a complete multitasking operating system inside the radio. So in addition to all the software that's inside the radio, we now are at a point now where we're gluing up a very thin client GUI or graphical user interface. So no more is the need to have a dodecahedron 9000 PC to run this thing. A very small client PC will work just fine. Think of it as sort of a super browser.
Will FireWire be required or a USB?
This is actually Ethernet based. It'll support Ethernet 10100 or gigabit Ethernet. And so we just felt like the fact that Ethernet is everywhere, it's ubiquitous, it's easy to handle, and oh, by the way, it lends itself very well to remote remote operation.
So you're saying I could operate if I had one of these at home, I could operate it from here using a computer?
I'm saying, yeah, the architecture was designed for that. I want to be very careful. The first release of the Smart SDR GUI will be designed to be inside the local area network. The reason is when you go out into that wide world web, there's a lot of security concerns, and we are working through those to make sure that the network is absolutely bulletproof on the outside. Okay. But the hardware was designed specifically for that. Think of this Flex 6000 series as a radio server. And you as being the client. So obviously you'd want to have more than one client operating the same radio, or one client operating more than one radio, and then certainly the ability to operate remotely is just a wonderful thing, and not with a lash-up, but with a direct client operating type. There are 2 basic radio types. We have the Flex 6500 with 1 spectral capture unit, which is that ability to grab all of the HF spectrum and put it in, up to 4 slice receivers, 100-watt transmitter with the built-in antenna tuner, and that radio is $42.99. We've also built a very high-performance contesting radio that has a second full spectral capture unit, so complete second receive unit with filtering, preamps, everything, and up to 8 slice receivers, over twice the processing power, and that radio is $74.99.
When do you anticipate the first person outside of the Flex Corporation will have one?
We are still committed to our beginning shipments in Q4 of this year.
Can you basically tell me what I'm looking at?
Sure. I'll just point. There in the center at the top is a 100-watt continuous duty transmitter, PA section. Over to the right and down, this is a new output filter section that we've built. This is actually a continuous half-octave filter. It uses 11 half-octave bands And what that's good for is not only will it work in the ham bands and meet full legal spec, but it also works throughout the entire Mars, Civil Air Patrol, and other radio services. Below and to the left is our antenna tuner design. This is the same antenna tuner architecture that we put into the 3000. That's a smart learning antenna tuner, so we're very excited about that. And in the little can in the middle, that's a new directional coupler antenna monitoring system, kind of lower to the right there, and that's used for doing sampling and measurement of the signal. This is where the business end of the compute processing. Up in the top, you'll see a square canned-in area. I've got the can off of it. There's two large fans. Those are fan heat sinks. One of them is a field programmable gate array from Xilinx, and we have two different sizes depending upon which radio. And that's what does all the heavy digital signal processing, the handling of the spectral capture units, and all the crunching horsepower. Then the other part is a complete media engine, which has got ARM9 based processors and TI advanced digital signal processing. And that runs basically a complete real-time multitasking operating system. So it's a complete computer up in the upper right-hand corner. Down below in that array, and yes, those are relays, and I'll tell you why in just a second, are all full bandpass filters for every ham band when you're running in contest or narrow band mode. And you can actually stage those and gang them to get multi-bands at the same time through the SCUs. So why do we use relays? It's a question people have been asking. And it's because a relay, when it's connected, is zero IMD, zero intermodulation distortion. We went to all this trouble to put no mixers. We have one master oscillator in there. The last thing we wanted to do was put a bunch of diodes in that were going to cause noise and distortion. If we've gone to all the trouble to get IMD performance of IMD DR3 of around 110 dB and phase noise at the bottom of minus 147 dBc, it would seem silly to put diodes in there. So that's what all the relays are for. We really went out of our way, spared no expense in this radio architecture to, I'll move this way here, spared no expense really to make this the highest performance radio that we've ever designed, and we believe it's going to be a chart topper as well with the community.